quick overview of trig equations. We're not going to look at every type there is, but we're going to try to look at sort of an overview. And in calculus, there's plenty of times when you'll go through and you'll solve trig equations. I'm going to start with the simplest variety. And the thing is, almost always these problems boil down to something about the unit circle. So actually, what my directions are on this, and I'm only going to look at the type of problem where I'm asking you to solve it from 0 to 2 pi. So that means immediately that what I'm looking for is I'm looking for radian answers and just whatever's in that interval. Okay, and that's pretty well all we're going to look at in this class. All right, so this one is kind of the standard. The trig function's isolated. So what you do is you just look on the unit circle and you figure out where that happens. Okay, that's easy to do. The cosine is the x value. So one place it happens is at pi over 6. The other place it happens is 11 pi over 6. So that's the only two places it happens. So this problem right here you can do in your head, and you just usually write the solution in a set brace, and then we'll just say pi over 6, and then 11 pi over 6 like that. Most all trig equations you do boil down to that last step. I mean, I've designed all of these problems that we're going to go through are going to be interpreted by the unit circle primarily. If they don't go to the unit circle, then you have to use your calculator, okay? So the next one just has one additional step to it. First thing you got to do is you got to isolate the sine. Okay, so you can kind of do this in your head. You don't have to show the steps necessarily. So I'm going to subtract 1 from both sides. So I get square root of 2 sine x equals -1. Okay, then I can divide both sides by square root of 2. Okay, so I end up getting sine x equals -1 over root 2 like that. And then you can rationalize the denominator if you want to, if you feel like you need to. So I'm going to go ahead and do that. So just rationalize, and then this will take you to a familiar place on the unit circle. So we get sine x equals -root 2 over 2 after you rationalize. So what you always want to try to do is isolate that trig function and then get to a point where you can look it up on the unit circle, okay? So what we're doing on this, and I'm going to show this step to you. This step really is not necessary, but technically you can think of this as taking the inverse sine of both sides. There's one little issue with this, though, that sometimes confuses students. So basically, if I do the inverse sine of the sine of x, I get x, and that's what I'm trying to find anyway, okay? But the thing about the inverse sine is when you solve a trig equation, you don't really need to pay attention to that range. The range of an inverse sine, we learned, is -pi over 2 to pi over 2. Okay, you don't really have to pay attention to that. And that's the reason to me this last step is not really necessary. So all you do is just figure out where this happens. There's two places where it happens. The sine is the y value. So it happens here at 7 pi over 4. And it also happens here at 5 pi over 4. So that would be the two answers to the problem. Would just be, we just write as a set, 5 pi over 4, and then 7 pi over 4 like that. Okay, so these problems usually aren't very hard to learn because if you've already got your unit circle down and know how to interpret things, then that's what you're doing anyway. Okay, does that make sense to everybody so far? Okay. Those are the basic ones. The ones that we're going to do are a little bit more advanced, just require factoring. Sometimes they require identities, but that's almost always the last step of the problem is just to interpret on the unit circle, okay? And all we're going to do is solve these in radians, one lap around the circle. Okay, we're just going to look at that situation. We're kind of limited in this class what we're going to do. Okay, so the next one, this is kind of where you get into some factoring and identities. So the other thing that you want to do is anytime if your trig equation has like a second power or higher, then you have to think about factoring. It kind of looks like a quadratic equation, so you kind of think of it the same way. You get one side equal to 0, and then you attempt to factor, okay? So the big deal is factoring this. Let's see, like if you have a problem like this, if you had x squared minus x equals 0, well, what can you factor out? You can factor an x out, right? Okay, so if you were solving this quadratic equation, you would get x equals 0 and x equals 1. And we looked at that, earlier in the semester. So what's the common factor if you have a cosine squared and a cosine then? It's a cosine, right? So you take a cosine out like this. You've already got one side equals 0, which you want, and then you just kind of multiply backwards. Cosine times cosine would give you cosine squared, and then cosine times 1 is going to give cosine x like that. Okay? And then from here, you do exactly the same kind of thing that you did back when you were solving quadratic equations. You set each factor to 0, and then each one of these will be interpreted on the unit circle anyway. So we're going to look at cosine x equals 0, look that up on the unit circle, and we're going to look at cosine x minus 1 equals 0 also, okay? So to begin with the first one, and you don't have to do the inverse cosine of both sides, because what you're really doing is you're looking up where the x value is 0. So how many places on the unit circle is x 0? There's 2 places, right? Okay, since we're doing a cosine, we're looking at that. So that means that 2 of your answers would be x is equal to pi over 2 and 3 pi over 2. It's a cosine, so you look at the x value like that. Okay, so those are 2 answers like that. Okay, the next one, what you have to do is you got to isolate the cosine first. So you end up getting cosine of x equals 1. Okay, so where is the cosine 1 on the unit circle? One place at 0. Good. Okay, so basically what you would have here is the cosine takes on the value of 1 at 0 radians. So that's a third answer to the problem right there then. Okay, so what we'd end up getting, our solution set, it doesn't matter what order you put the answers in. So we have 0, pi over 2, and then 3 pi over 2 like this. Okay. Now what I'm going to do is I'm going to have you do something on your calculator on this problem. I'm not going to do this on every problem, but it's good to know, particularly if you're in higher math and everything, and if you want to make sure you're right. These problems are generally easy enough, at least the ones we're going to look at, that you'll be pretty confident you're right as long as you do the factoring correct. But try this in your calculator, and this is a good thing to know. We're going to put in the left side of this equation. And the way you have to put in cosine squared, you have to go like this. You've got to go cosine x, and then you got to square the whole thing like that. So you have to put that in like that, and then we're going to put in minus cosine x, and I'll show you how to get the window set up and everything. I just want to show you that it's real easy to check and trace out these answers. So the first thing we want to do is just get the function put in. And then you want to make sure you're in radian mode. So check and make sure you're in radian mode. And for the window, since we're solving the equation on 0 to 2 pi, that's what I want you to put in. I want you to go 0, x max will be 2 pi. And it doesn't matter what you scale by. You can scale by 1 if you want to. That's up to you. And then for the minimum, well, we know the cosine reaches a high of 1 to negative 1. So now this will change the graph a little bit. So I'm just going to do something like negative 3 to 3 and just kind of play with the y value like that. And then if you got everything set up okay, then what you would end up having is you'd have your graph. We haven't looked at a graph that looks like that before, but that's the graph of cosine squared minus cosine x equals 0. Well, we got 3 answers. All you got to do is trace it out. So if you trace the first answer 0, the reason it's right is because y is 0. And remember, the equation was set equal to 0. The second answer we got, you can trace pi over 2, and see that also is right. That gives you y equals 0, so that's got to be right. And then the other one's 3 pi over 2, so you can go trace 3 pi over 2, and that works too. Okay? So you can tell you're right visually on these things, and that's a reasonable thing to learn how to do, particularly for higher math. You're solving an equation, just make sure you got it right, and visually you can always do that if you want to. All right, does that make sense to everybody, what I did there on the calculator? Okay, all right. So I just wanted to do that one time and just kind of remind you that, yeah, you can do that, okay? All right, so the next one, again, we got one side equals 0. That's what you do when your trig equation has a power of 2 or higher. Then you just kind of look at this the way you would a quadratic equation. So if you had, instead of this problem, if you had this instead, you've learned how to solve that. You factor that, okay? And the way this would factor is like this. You would have x times x to get x squared. You'd have 2 times 1 to get 2. And then to get that middle term of 1, you'd have a plus and minus, right? So what would be the answer to that equation? Negative 2 and 1, right? So we do this the same way. And sometimes students need to make the connection that the factoring works the same way as it does, like on the problem I just showed. So you do the same thing. Okay, the first term is going to be sine x and sine x. The last term is going to be 2, so that's 2 times 1, so you get that. And then that inner term, see this inner term would be a 2 sine x, and you don't have to write this down if you don't want to. Then that outer term is 1 sine x. You're trying to make that add up to positive sine x, so what you get is you have a plus and a minus like that. Right, so that's how the factoring goes. So if you factor something, you want to multiply it out and make sure you did that right, okay? Then what you want to do is you got 2 factors. So just like the last problem, set each factor equal to 0, and then solve each equation. Again, I'm designing these problems so they go to the unit circle. If they don't go to the unit circle, you'd have to use your calculator to get a decimal approximated answer. Okay, what you would do on this one is subtract 2 from both sides. You can do that in your head. So you get sine x equals negative 2. All right, now remember on a unit circle, what's the sign? The sign's the y value. Is the y value ever negative 2 on a unit circle? No, so that's no solution. Every now and then you'll use one of your factors and it won't give you anything, okay? And another thing is too, like if you took your calculator, if you did the inverse sine, oops, that's not what I wanted to do. If I did like the inverse sine of negative 2, well, we learned that's out of range anyway, so you're going to get an error, see. So that one's no solution. So the next one, you can add 1 to both sides. You can just move the 1 to that side. Okay, so what's the answer? Where is the sine 1? What angle? Pi over 2, right. Okay, good. Okay, so the sine takes on that value of 1. The sine's the y value, so that would be at pi over 2. So actually, the only answer to this problem would be pi over 2. Okay, you can have sometimes you have no solution. You may have 1 solution, 2, 3, 4 solutions. It all depends on what the equation is. Okay, so those are factoring, and you want to make sure that you know how to handle this kind of thing. Okay, the next one also factors. So what we'll do on this is one you have to kind of do by trial and error. This is the type I see students tend to have a little more trouble with. But the first term would be 3 cosine x and cosine x. It couldn't be anything else. The second, the last term is going to have to be a 2. So you could either go 2 and 1 or 1 and 2. The order makes a difference. So let's start by trying it this way and see if we can make this work or not. Okay. This one may have, let's see, if I go the other way, I don't think it'll work the other way. I wonder if I gave a problem that I didn't intend to give. Okay, yeah, that's what I did. Okay, you'd have to use quadratic formula. I want you guys to change one thing, okay? I think I typed this on here. I'm not going to cover the kinds of problems that are trig equations where you have to use the quadratic formula, okay? We're not going to worry about that, okay? So just change that to a 1, and then what would happen is this would be 2 cosine x there. This would be 3 cosine x here. And then you're trying to make that middle term add up to negative 1 cosine 2x. Technically, you could solve this with the graphing calculator quadratic formula. We're just not going to worry about that situation. So anyway, what you'd have is you'd have to have a plus 2, and you'd have to have a minus 3, so that 1 would have to be negative to get that to happen then, okay? I'll finish this problem because part of it's going to be a calculator thing anyway, which is okay. All right. Okay. Everybody with me okay on that? Okay. So what I do in like on next Monday's exam, I'll give you probably a factoring problem kind of like this, but it'll go to the unit circle. Okay. I want to make sure that's what we're kind of limited to doing. So what we do is we set each factor equal to 0, and then we solve each equation. The first one I think we'll have to use the calculator on, which is okay. I want to show you that. Okay, so what I'm going to do is subtract 2 from both sides, and you can do that in your head. You're just moving the 2 to the other side to get this, and then you're dividing by 3, so you'd end up getting cosine x equals negative 2/3. Now, that's not one of the magic numbers on the unit circle, so there is a place on the unit circle where x is negative 2/3, but it's going to be something you have to get your calculator out to do. So what we end up doing on this then is we do this. Okay, we're going to do x is equal to the inverse cosine of negative 2/3. And we're going to get this in radians, so you want to make sure that your calculator is in radian mode. And the calculator is only going to give you one answer. What happens is one of the things we learned is when you have an inverse cosine, the range of an inverse cosine is from 0 to pi. Since that's a negative 2/3, it's going to put you in quadrant 2. Okay, so I'm going to go ahead and just go inverse cosine of negative 2/3. And then we're just going to round this off. This is a radian answer, so we'll round it like to 1 decimal, okay? But that's not the only answer of the problem, is the thing you got to pay attention to. So we would get x is 2.3, and what that is that's a quadrant 2 answer, okay? So what you have to do, this is the part of the problem that sometimes students struggle with a little bit when you have to use your calculator, is it goes like this. Basically, 2.3, remember pi is 180. So pi is 3.14. So 2.3 is in quadrant 2 in terms of radians. So what you have to do is there's 2 places on a circle where the cosine's negative. The cosine is negative in quadrant 2, but it's also negative in quadrant 3. So we have to figure out this reference angle on here like this. So what we do is, this would be that's an appropriate answer to the problem right there. But what we have to do to get this reference angle right here, to get that reference angle, we got to go pi minus 2.3. Okay, because we're going halfway around the circle less 2.3. That'll give you the reference angle, which will allow us to get the quadrant 3 answer. So I have to go like this then. So I have to go, and I'm in radian mode, so I got to go pi minus 2.3, and then I'll just round this off maybe to like 2 decimals or something. So this reference angle is about 0.84, all right? And you're not used to reference angles being in radians too much, so that would be 0.84. So that means this reference angle would also be 0.84. So you got to give me the quadrant 3 answer. What do? You would go halfway around the circle, right? Plus the reference angle. So what do? You do pi plus 0.84 gives you the quadrant 3 answer then. That's the hardest part of the problem to me. So what you got to do is you got to do this. So your quadrant 3 answer, you do pi plus 0.84, and then that'll give you a second answer to the problem then, okay? And this goes like this. I'll just use my pi key, and then plus 0.84. And that'll give about, we'll just round that to about 3.98 then. Okay, so we also get x equals about 3.98. And that's quadrant 3. It's bigger than pi. So that would be a second answer of the problem. Does that make sense? Students a lot of times seem like they have a hard time catching on to this part of the problem sometimes. The calculator only gives one answer, but there are 2 places where the cosine's negative. Cosine's negative in 3 and 2. So you have to figure out the reference angle to get that quadrant 3. Does that make any sense? Okay, pi minus the reference, minus the 2.3 gave 0.84. Okay, and the rest of the problem is actually easy. This part right here is easy to do on the unit circle. So you can add 1 to both sides. That'll give cosine x equals 1. So where is the cosine equal to 1 on the unit circle? There's only one place. Where is that? That's 0, right? Yeah, the cosine is the x value, so that would give x equals 0. So those are the 3 answers to the problem, and 2 of them we had to basically use the calculator on to get that. Okay, so generally we just write it like this. We'd have 0, 2.3, 3.98. You just write that in a solution set. Okay, this is a problem, again, you could graph the left side on your graphing calculator and trace out those 3 answers, and they would be equal close to 0. So it's checkable when you do that. Okay, so that's one that I do want you to be able to do with a calculator, is be able to figure that out. Any question on that? Okay, let's see. So I'm going to do one more thing, and we're going to kind of limit what we do on identities in here. The kind of problems that I've given you that we've gone over, the most common types that you encounter in calculus, just kind of straightforward trig equations. You also, from time to time, encounter ones that have identities in it. So what happens on this is this has a sine of 2x in it. And we talked about this identity last time, and that identity is 2 sine x cosine x. Okay, that's in 6.5. So we're going to use that identity. If you don't use that identity, you'll have a hard time getting this problem to work out a certain way. So what we're going to do is just replace with that identity. Then it will be something we can solve by factoring. Okay, so your first step is replace the sine 2x with 2 sine x cosine x, and then bring down the minus sine x like that. Now remember, you want to try to look at factoring, and if you want to solve by factoring, one side's got to be 0. Okay, so how do you factor this anyway? Is there a common factor? Yeah, sine x. You want to take common factor out. Don't forget about common factors, okay? They show up all the time, okay? So what you want to do is you want to take sine x out, okay? Then it'll work beautifully. So we just take sine x out. Then you're left with 2 cosine x minus 1 equals 0 like that, okay? And then once you get that, then it's the same kind of principle that's going to apply to that. So you have to use an identity on some of these problems, okay? So you'll have to do this problem this way. Now what we'll do is we'll just go to the unit circle. So we set each factor equal to 0. Like I said, these problems always end up with this last step. If you factor, you have to look at each factor equals 0 and then go to the unit circle. Okay, this is usually the easy part of the problem. Okay, so how many places on the unit circle is the sine 0? 2, right? Okay, there's 2 places. Okay, what's the sine? The sine is the y value, right? Okay, so that means that happens in radians at 0 and pi. Okay, so that would give you 0 and pi would be 2 places where the sine of x is equal to 0. Okay, then the next one we do the same way. This will fall on the unit circle. You can add 1 to both sides. So you get 2 cosine x equals 1. You can divide by 2. So you get cosine x equals 1/2 like that. Okay, how many places on the unit circle is the cosine 1/2? There's 2 places. Remember, the cosine's the x value, so it happens at pi over 3, and it also happens at 5 pi over 3. Okay, like that. So what you'd end up getting then is you would get 2 other answers. You get pi over 3, and you get 5 pi over 3 like that. Okay, so if you put it all together, doesn't matter what order you put these in. I usually just put them, kind of order them. So 0, pi over 3, pi, and then 5 pi over 3 like that. Okay, that one's just an example of one where you have to use an identity on. So we're going to look at one more of those. Okay, all right, any question about that? So if you see something like sine 2x, cosine 2x, think about identities. That's probably the extent that we're going to look at here. So what I want to show you on this next one here is, and you don't have to write these identities down. We learned this last class. Okay, the first identity we have is cosine squared x minus sine squared x. This is the one that had three forms to it. The other one was 1 minus 2 sine squared x. And then the other one was, let's see, I always have to derive this. So it's cosine squared x minus 1 minus cosine squared x. So that one I think is 2 cosine squared x minus 1. Now I'll give you these identities. On your exam before I give you identities, and you want to probably check Canvas probably tomorrow. I'll probably have the formula sheet I'm going to give you, okay? So you want to know that. I'll give you a lot of identities on this exam. Well, actually, you can use any of those you want to, but the best one to use in this problem is this one. The reason is you already have a cosine. So you want to try to avoid having two trig functions in your equation. Most of the time, not always. So that's why I'm going to do that, okay? You might run into some problems factoring if you use the other one. So again, just change the cosine of 2x to what I have highlighted over here, 2 cosine squared x minus 1, and then bring down the minus cosine x like that equals 0, okay? So we're going to do that. Now this would be something that we can probably factor. It looks like it factors. So before I factor this, I would write this as 2 cosine squared x minus cosine x minus 1 equals 0. And then we'll try to factor, and if it factors, we'll solve it like I did previous problem. Okay, is everybody with me? Okay, what I did on that? Okay, remember, you're trying to think about factoring a lot of times on these problems. So the first term would be 2 cosine x and cosine x. And then the last term, 1 times 1 is 1. So you got to make that work out, and I think that works out okay. So you would have this, and then you would end up having, if you're trying to get a minus cosine, you'd have to have a minus and a plus right there. Because again, you want to have minus 2 cosine plus cosine is that middle term minus cosine. Okay, so make the inner and outer come together and make sure you got that right. Okay, now from here, this one, you're going to set each factor equal to 0. So you'll have 2 cosine x plus 1 equals 0. That'll be straightforward unit circle. And then cosine x minus 1 equals 0 like that. Again, you can rearrange in your head if you want to. This is 2 cosine x equals negative 1. Subtract 1 from both sides. Divide by 2. So you get cosine of x equals negative 1/2. Okay? All right, look at my unit circle. There's two answers. What are the two places where the cosine's negative 1/2 in radians? 2 pi over 3. What else? Yeah, that one down there, my unit circle is kind of blocking that one point, so it goes like that. So this would be one place here. The other place the x value is negative 1/2 is 4 pi over 3. Okay, so that means this particular part of the equation would give you 2 pi over 3 and would also give you 4 pi over 3. Okay, like that. Okay, then the next one, you can add 1 to both sides. Cosine x equals 1. Where is the cosine 1 on a unit circle? It's only one place. Where is it? At 0. Good. Okay. Yeah. So the cosine takes on the value of 1 at 0 radians. All right. So those would be your answers to your problem. This one has 3 answers. So those 3 answers would be 0, 2 pi over 3, and 4 pi over 3 like that. Okay. That's it. Okay. So you've got a couple of things with identities. Lots of other trig equations you encounter, but these are the most common that we want to look at in this class, okay? Because you're going to see this a little bit in Calc 1. From time to time, you'll have to solve trig equations, okay? And these are the typical varieties that you'll see. All right, any question on what I did? You guys feel okay with what I did there? Okay, mostly it's unit circle.